a great opportunity to have an actual workshop. So this is meant to, he's going to tell you all this, but this is meant to be very interactive, I'm guessing. And he's even willing to do some demonstrations if people have questions. So without further ado, Dr. Dan Poenaru for us.
Thank you. Thanks very much. No, don't do that. No. We're not going there. So yeah, I'm Dan Poenaru. Just for those of you that have not ever seen me before, yes, I'm obviously an emergency researcher, but I'm primarily a pediatric surgeon. I was in clinical practice for many, many years, and then global practice, and then basically came back and got my FRQS very late. So I got into research. And then COVID came, and it was really, really slow going and boring. And for hours and hours, I started listening to podcasts and things about AI, which I didn't know anything about. And basically, that got me, for the past 4 years, actually, I've been seriously involved in AI, healthcare AI research. I managed to get myself in MILA, which you may know is the Quebec AI Institute, and really found myself to be the only active clinician at MILA out of 1,000 AI scientists, including healthcare. And realized that at the time already, my role was very much to be a bridge, like a translator, like an auto-translate between computer scientists and clinicians, because we speak completely different languages, of course. And that worked well. And over the years now, we've got 3, 4 PhDs that are computer scientists besides the other ones, and they work together. And we got a little bit of that thing going. But from the beginning, I was an early adopter of AI, really into this stuff, of course, and use it. So I fell right into the hype of it. And then things happen along the way, and you'll see sort of some of the things that happen along the way. So this should be working. Why is it not working?
I think that's okay.
No, it's good. It's good. So yeah, so a little bit of introductions, which I've started now, and then talk a little bit about this is not all AI. And by the way, just to be clear from the beginning, this is not about submitting proposals, research proposals that include AI to CIHR or anywhere else. That actually is coming in February at McGill in CIHR preparation. I'm actually going to do that section, and it's already prepared. This is very different. This is just in your regular life. This is about using AI as a student, as faculty, how to cheat, how not to cheat, and all that stuff. And we'll talk a little bit about LLM basics, generative AI basics, then show you some of the uses in our lives as researchers, misuses, abuses, and then play with some real life examples. And really, the whole thing should be an hour. Anything beyond that is going to be, if you ask me to do stuff to see what comes out and to sort of practice a little bit. I thought for a while to do it yourselves on the computer, but this is sort of going to probably work a little bit better this way. So in terms of introductions, I introduced myself. I want to introduce you to my 2 research friends, generative AI and predictive AI. You wonder what on earth are these doing there? I'll leave you thinking and not knowing, and it'll come through the conversation. You'll see why my 2 friends, one of them looks the way he looks, and the other one looks the way she looks, or he looks, or whatever. So that's just to get you paying attention. So we'll start a little bit with LLM basics. Like you've all heard about it. All this, this is a sort of next word prediction type of a thing somehow, which became really, really smart. So autocorrect not on steroids, but on nuclear power type thing. Really, the way I try to get it into my head works is that, when GPT came, and it was called GPT, the T is a transformer. So basically, this whole thing, LLM, generative AI, all of generative AI, is a form of deep learning. And when I say deep learning, it's basically the basic AI, which is machine learning, that gets deeper. So there's layers in between the input and the output. And because they're inside those layers, we have no clue what happens there. We plan them to do something, but it's black box. That's what the black box in AI is. It's deep learning, is the fact that between what goes in and what comes out, we just don't know how exactly it does it. And that's a classic thing with LLMs and the problems that we have with LLMs. If you, for example, think about the major strawberry problem, I don't know how many of you have heard the strawberry problem. Strawberry problem is how many R's are in the word strawberry. ChatGPT 4.0 I cannot get it right. Cannot tell you that there's 3 R's in it. Why? Nobody knows, because it's deep learning, right? That's just as an example. So it's deep learning, and it's a form of deep learning that's called, well, we call it neural networks because it's sort of, we think it's how the brain thinks, because we know that in the brain, histologically, you've got those things that go in layers. The neurons are in sort of layers of neurons, and each one connects to more things. And somehow was smart enough to say, oh, let's create this like a neuron. And then we got these neural networks. But the point of this is that basically there is one model that gets created in this deep learning that processes the input towards the output. Now, generative AI deals with two things, deals with words and pictures. Words is the commonest thing, but pictures, you see it all the time around. My previous thing was a picture like that. That's because that needs a transformer, because the computers have no clue what a word means. So you transform the words into numbers, right? Little long numbers, 0, 1, 1, 1, 0, that sort of stuff. And this is obviously a non-computer scientist explanation for what happens here. And to do that, you have what is called a transformer, which takes each word and breaks it down into what it calls tokens. And each token has a number. And that's how you can then do computations on the words, because you now have numbers, not words. The problem is a token is not a word necessarily. It's not a syllable necessarily. It's how those layers decide to split a word. And therefore, that's actually why the strawberry problem exists, because it doesn't know how many tokens. We don't know how many tokens end up being in the word strawberry. Then there is something else which is very important that was added to transformers. We had transformers for a while, and that's the attention. There was a paper quite a few years back that was famous. It's the most famous paper in AI. It's called "Attention is All You Need." And attention means that at that time, they were talking about natural language processing, right? They take the words and they try to figure out what they mean. But attention means that the computer keeps track of which word comes when and the order of the words, which is the whole huge difference, so that we understand actual language, which is not one word in any set of context. So attention is very important. But then they figured out that when you have a text, even just one page of paper, and you've got all those words there, and there's more tokens than words. And for each token, you need to keep track of all the ones that were there and so forth. Once you create a large language model, it becomes horrendous, because basically what you do in a large language model is you take every text that you can get your hand on the internet, that stuff, and a lot of it that you don't have the right to do it, and it's been completely unethical the way all the big companies, starting from Meta and going through OpenAI and Alpha, they're all scraping stuff, and at least half of the stuff is not their own, and yet they're taking it and just putting it in there and then training this big neural network model. But it's like, imagine now millions and billions of words. In fact, it's billions of tokens that they have. And the standard model nowadays is like 100 billion token model. Each one, it needs to go every time to all the words and to remember which place it was in so that it can autocorrect for you at the end of the day, because that's what most LLMs are. It's autocorrection. And obviously that happened through a lot of innovation, which was this efficient parallel text. So they can actually, when they have a sentence, they actually start from every word of the sentence at the same time. So there's parallel processes, because otherwise it would take years, right? So that's the core architecture. The essential components, word to mathematical representation, I explained that, and multiple neural layer information processing, and an attention for connection identification of connections between words. So how do you generate text and how do you generate images? Interestingly enough, so it's all using one model. You know how if you put any project, any proposals with AI, you got to this data and you try to predict something, and you're going to use random forests, and you're going to use machine vector models, and you're going to use KNNs and so forth. Those are all models, different models. The cool thing with deep learning is that it's only one model. It's this deep learning thing, which basically what it does, it's all the same. The whole difference is what you put in it. You put a bunch of Wikipedia articles or textbooks or whatever words, or you put a bunch of images. It doesn't care what it is because they all get tokenized, right? Just different way you tokenize a word from a picture, still same difference. And then once you're in the model, you're starting to create a prediction, whatever the outcome should be. In this case, what's for LLMs, what's the most best next word in the sentence, right? Based on 100 billion tokens. And what it does is the model is called diffusion descent because it basically it just optimizes for getting as close every time the slope is closer to what you're supposed to have. It goes faster, so it goes towards those slopes. So it's a descent type thing, and that's how you get the actual output from there. But the differences is, as you say, so for the foundation for text generation, you have these data sets. And once you've developed a model, then it can predict the next best word when you have a prompt, right? When you have a sentence that's going to complete it the best way it can. Now, most models are also pre-trained. They're all pre-trained. That's GPT, generative pre-trained transformer. That's GPT. They're pre-trained, but you can also specialize train them or fine-tune them. And that's where they came up with medical, research, biomed, LLMs, and so forth, where it's a bit more better information that's in your domain. How much fine-tuning did is less clear, but it makes sense that you would fine-tune it for that. In image, it's a little bit different because in image you have this gradient. So there was gradient descent was your LLMs for words, and it's gradient diffusion for images. And what that means is that it's still trying to get as close as possible, but to generate a cat, what you need is you need to train the model on 1 million cats, right? And the way it's going to be able to recognize or to create a new cat, right? But to do that, it's a funny thing with images. It actually goes back and forth. It does forward diffusion. So what it does, it takes all those cats and it decomposes them to nothing. Cat people, I'm sorry if I offend you. We can use dog analogies. It's just going to decompose it. It diffuses it just like a bad picture, pixelated picture. It adds noise till it becomes all just gray, one square of gray. And that process of how to get from a cat to nothing is memorized as part of the training. So that way, when you then say on your computer, give me a cat, it thinks, cat, I know how I decompose them. I'm going to reverse engineer them now. I'm going to go and I'm going to make a cat out of nothing. And that's really how it happens. Forward and reverse diffusion for image generation. So we're getting a bit more practical now. This is by far not inclusive. It is a bias list because it has the three big ones plus the one I like. That's why it's a bias list. ChatGPT was the first kid on the block, of course, pioneer. Now it has this very, very secretive 4.40, where I apparently does not stand for idiot, but it stands for intelligent. That's because they came with a brilliant idea, which actually has been done already by others, but they popularized it to make it think. Slow down, OpenAI, think. And it actually gets better results because it actually thinks for each step in the process. That's the adaptive learning capabilities. And it's very good for just about anything. It's fine. It hallucinates in multiple ways. We'll talk about that part. Anthropic is actually my second favorite, Claude, because it is a more academic one. Even their website is sort of cute and it appeals, I think, more to the academic. It is more research optimized. It always had a huge context window. Context window is how big a text can you put in it to look at. And 2K tokens is more or less around 200,000 words, which is a big PhD thesis, right? So it can do, it's got a lot. At the beginning, when these models came, they typically had like 4K, 1K, 2K, 4K window, which is one piece of paper. That's all it can memorize because it's a huge amount of electricity, right? This is where these LLMs use the same as entire countries, because for every word, it just needs to sort of take it, go back, now state what's the next word, what's the next word, what's the next word, and so forth. Gemini came because Google is, and it's big at the only asset I know. It's not better than any one of these things in any way, except that anybody that uses Gmail and uses GDocs and all that stuff that I use, it's already in there. And for a little bit of money a month, research funds, you get Gemini to help you reword this document and stuff like this. I don't use it very much, but it's all right. Perplexity is my favorite. You'll see it in action because I'll be using it for this thing. And what Perplexity was created, it's much smaller than these big guys, but it from the beginning it had real-time internet access. I don't know if you remember, but when GPT came, you could ask any question you wanted until July of 2022 or something, because it stopped learning then. And now it's not an issue. All of these have internet access, of course. This one, Perplexity, had it from the beginning. The most important thing for me is that Perplexity was actually created as a search engine. Their overt goal is to dethrone Google. Search, Googling. And because of that, they knew that they need to be very clear about the quality of their responses and the citations. So it had, from the beginning, I didn't have an extra option. From the beginning, every word, every statement that Perplexity gave me, it had a little reference. I like that as a research. I click on the reference and it was actually correct. the references were correct and they were to the right things. And you could tell it, go, I don't want references from Wikipedia or from magazines, from Chatelaine. I want only PubMed refs or archive. For me, I always put it's PubMed and archive because those are at least scientific references. So that's that. But they each come, of course, with their pluses and minuses, and there's a lot more than these. So this is the main sort of thing for this workshop. It's this listing of what I think are places where you can use this LLMs. It's 100% incomplete. It's 100% biased because I wrote it. It wasn't ChatGPT or Perplexity that gave me this, although I could have done it. So first of all, a researcher can use it, and I use it sometimes for generating ideas. When I'm stumped, when I don't know where I should be going, where there's something in the research that's missing, when I'm trying to figure out what study I should do for this or in this area, it'll give me stuff. I'll ask it and it gives me stuff. The good thing about it giving me stuff is that I take it at face value. It's like, that's an idea. Nah. Yeah, no, whatever it is. Nobody's life is in danger. No unethical thing about this. It simply gives me ideas. From the beginning, in all circles, because we'll talk a lot about how the research community, just like the educational community, face the sort of rise and fall of AI anxiety and all those things, about avoiding it, stopping it, all that stuff. So this is very, very, very fair. Or, for example, I have a question, I want to fix it, I want to solve it. I actually asked it, how would you do this? Like, what methodologies would you use? 50-50. But the point is that I know the 50% that are not good. No, that's not going to be it. But the 50% that are good is like, that's a good, that makes sense. Sure, yeah. Why don't I use that? It's a little helper. It's a little friend that helps. The picture at the beginning of that crazy, I always called AI my crazy drunk friend. And it's really the relationship that I have with AI is that it's a friend. It's not a foe. It's not an enemy. It's a friend. I just need to take them with the right in the right context. Sometimes they're crazy and sometimes they're utterly drunk. And that's why I use that term. And even the picture is sort of a little bit like a crazy guy. Then I go on after my project and I'm going to do my little literature. I know I may need to do maybe a systematic review. I don't have time for a systematic review. I just want to know if anybody's done anything in this. I'll ask it to do a literature scan. Very easy. One simple prompt. Do me, find me all the references you can about this and this and this and this. What's going to happen there is that it may absolutely miss references that are very important. This is not a systematic review, but the ones that are there, especially if I click on it and I see that it's the real thing. And for Perplexity, I don't have much. It doesn't hallucinate anywhere close to ChatGPT with the actual references. So they're actually correct. That study has only the studies actually in Chinese or in German or whatever. Just click of the button, give me the stuff in English, and it just doesn't think about it. The translation capability, and we'll come back to this many times. The translation capabilities of any of these LLMs are way superior than anything. Let's say they're better than any non-native, like let's say English to French, because we're here in this environment and we're doing this. We're actually translating all of our stuff that we need into French. They're not as good as my one colleague who's from the academy and who lived in French their whole life, and it's just French, but it is definitely as good as any bilingual Montrealer. Let's put it this way. In other words, it's really good. And you can actually say, translate into Quebec French if you want, and it knows Quebec specific things, I suppose. Not that you need that for your documents. Multi-language article summaries, extract structured data across articles. So we're getting here, we're pushing the envelope a little bit here. By the way, there's a whole cottage industry of labs out there they've been trying it for 10 years. I know because I've been reviewing the grants on these people that want to automate systematic reviews. It's such a pain to do these automated reviews. So there's actually there's a Canadian group that it's all purpose, I think out of Western. Their whole raison d'etre is to automate systematic reviews. It hasn't happened yet. LLMs have brought that immediately 90% there. It's definitely going to happen. We're doing it in our lab. We're got research on all the five steps of a systematic review. Each one of these, we're seeing how we can automate it with LLMs, and it's going to work. And we're going to obviously show it that it's just as good as the actual systematic review is done. But it's not happening yet. So I can't ask it to do that. However, there's nothing wrong with saying, here's 5 papers that I got. Can you just summarize them for me so I don't have to sort of go through each one? And this is not for publication, nothing ethical about this. It's just for myself. I just want to know what's the theme, what's the idea here. No problem. Third one, scientific writing, biggest probably one that we're going to talk about and use. Fine-tuning, wordsmithing, it's just so good. The first prompt that I just became part of me is reward for flow, because all the students would send me these proposals and these things, and sometimes I stop at a sentence and it's just dead. It's just a dud. And then I would spend 5 minutes trying to reward that one sentence that is not right. Now it's literally just one prompt, and it does, like, I've never seen it do it the wrong way. It's so good because it autocorrects every word, and it just has a nice flow for that specific point that the student is trying to say. Of course, I look at it afterwards. Errors, stuff like this. You'll see in my prompts, horrible misspellings. I've stopped spelling my stuff when I write to ChatGPT because it cuts through that right away. It knows exactly. You'll see. Then you go, of course, into a step further, and that is document summarization, where you can summarize a big thing, big paper, summarize it in five sentences, in 10 sentences, in 2 sentences, whatever you want, it'll do it. And not too bad. Pretty well, it will do it. Shortening is great for that, which means that, of course, it's great. You'll see one of the prompt is, this abstract has 450 words. I need to be down to 250. Now, nothing tells you that it's going to include the right thing in there, but it will give me a 250 word. And then I go back and I see there. Again, notice from the beginning a theme, a leitmotif here, which is that's why I have no issues of intellectual property with AI. That's why I have no issues about ever I would never dream of putting AI as my co-author or something silly like that. It's doing what a good secretary would do, a good assistant would do, stuff like that. And I don't put that in my paper anywhere. And it's not an ethical. This text was typed in the old times by so and so. No, we don't write that in our as an acknowledgement. Gets a bit more, and you're going to see that we're going into stuff that, in fact, is specifically the data analysis and visualization. You'll see because of the McGill guidelines, and I'll go through those as well, for ethical use of AI. It gets into a bit more riskier stuff. I don't make it analyze data for me. That's probably not right either, but I definitely submit my research, my methods, and my little statistics, and say, does it seem right? If it says yes, it means nothing. But if it finds no, you used this type of statistic that you shouldn't be using here, it's like, thank you very much. That makes sense. So it's good for reviewing analyses. It's great for code, right? You heard that all these LLMs are great for writing code. So the engineers love it. And indeed, it's like my son who works in IT. I mean, most of the stuff he does, it's on GitHub. It's the GitHub pilot, which existed like for 2 years, 3 years now. And it just fixes all your code. For us, the rest of us, like, I dabble with R. I wish I knew. It's my students that really know R, but it's great because I ask it, so how would you visualize this? Oh, I do a bar chart, I do this. Can you give me the R? Gives me the R and copy it, I paste it. Oh, yeah, it looks good, and that's just the machine part of doing something like that. And it can suggest when you have data, which way to visualize them. Sometimes right, sometimes not. That's up to you to decide. Finally, administrative tasks. Oh man, it's good for this. Anything that's really boring, it's great for, right? That's the point, is that's again why it's not an ethical issue so much, because it's like, yes, who wants to be the one? Do I want to claim that this my annual report, I've written it myself? No, it doesn't matter, as long as it's a good annual report and everybody is included and all that stuff. So I just feed it. I'll show you an example. I feed a whole bunch of documents from our meetings from the whole year. And Chang, you got your annual report, very nice. And then you start working on it. It's a draft. It's always a draft for stuff like this, right? Summaries, it's always a draft. You can write letters, you can write reports on various things. You'll see the importance of context. You always have to give it very clear context, what type of writing, what type of information, and so forth. Talking about, so here comes the most inflammatory one, I think, for this group is the CVs, is writing reference letters. I don't write ever a reference letter for a student using AI. But, well, for one thing, because for the last 3 years, I've not written reference letters, because I always ask my student to write their letter, and then I decide if that's correct or not, because they know exactly what's the best. And in many ways, I find if the letter sucks, if the letter is not of good quality, then that reflects on the students not being able to identify what's important and so forth. So I'm usually going to leave it like that, because it's their own. I don't want to lie. I don't want to say that they are the brightest top 2% of my students when they're not. And if the letter is in the bottom 50% of the letters that I've seen coming from students, it's just what it is. I would be liar to sort of, I'm going to try to inflate it a little bit. And then the student always inflates it. And that's great. That's fine. They need to know how to inflate it. We'll talk about that. But if I absolutely have to write a letter of reference, maybe for a colleague, for something important they did, oh yes, I did that for nominating them for some prize. I put all my heart in it, but I did not want to go to their CV and quote which prizes they got and all these. I mean, these are 50-page CVs. So that worked perfect. Just give me a paragraph on all their achievements, and then I can go on with my real task of actually saying why I think that they're worth it. And then REB, talk about it. Boring things to do. REB documents, I don't think, I'm on 2 REBs. I don't think that they worry too much about that part if it's done well. And that's just about having for example, a classic example for REB is you've got your grant proposal that's done, that's approved. Now you got to submit it for REB. Well, it should be the other way around, but anyway. Now it should be submitted for the REB. Well, REB has got its headaches. No problem. I'm just going to give it a model of an REB template. I'm going to put my grant in there, and it's going to create a document with the titles and the headings that you need to have for that, and the lingo and all that stuff in there. So that's just a bit of an overview on general applications for research. Now I have an extra one, just because the slide was too long, for scientific dissemination. And what I mean by this is visual stuff and other stuff here in terms of really your KT and your dissemination of your work and so forth. And this is where, first of all, presentation. designs. I'm going to show you. This is what I use now. I've given up. I've stopped using PowerPoint and stuff like this. This is in Gamma. What you're seeing here is Gamma. And I'll show you how Gamma creates this in 1 second from the content that you give it for. Generate AI presentations from outlines and stuff like this. You can of course generate illustrations and visual aids. I have to say that it was a very, very, very embarrassing moment for me when I'm doing this research foundations fundamentals for McGill. We're 2-year for first year and second year med school, and they need to learn about research. And we assign them they choose their paper, and then they're going to do a little PowerPoint on a journal club, critiquing the paper. Well, this year, for the first time, I've done it for several years. This thing, for the first time, 2/3 of the group actually use Gamma because somehow they found out about Gamma or whatever. I can tell immediately when it's Gamma because it's got this is the Gamma look. And it was horrible. It was horrible. There was no critique. There was no personal reflection at all on what they did. It was just spewing up a few things. And then every slide, one thing Gamma is terrible at is that it just loves AI images. Now I'm part of their developer group, and we told them, you got to give us an option to never use ever AI generated. So you got all these plasticky, weird doctors, nurses in blue uniforms with 6 fingers and masks that go like this and stuff like that. And they never noticed it. Like, come on, guys. I need to fail you, but I don't want to fail you. So that's visual content. I'll show you that. But I've used some in this slide, as you saw. Patient education, of course, that's a great place for AI. You got to watch it also because it can say stupid stuff, but usually it doesn't say stupid stuff. And like diabetes education or this. And I want some visualizations. I want some stuff there. Such good. And then we're in Montreal. Oh, you wanted this in Arabic? No problem. Click. It's in Arabic. It's just so simple to do this because of the translation and all that stuff. So there's huge uses for this sort of stuff. I can tell you that for our consents, I mean, it used to be that, no, for our app, we got this app that we're developing, and it has to be in French, not just in English. And 5 years ago, we would have hired MUHC, RI, whatever it is, MUHC translation services, and they would spend, the problem is not how much it costs, that's a grant, okay, but they would take 3 months to do this stuff. It's like, come on, I'm going to do this, and then I give it to a good friend who is a primary Francophone literate person who just says, yeah, that's good, that's fine, Right. So now we come to the good, fun stuff of ethical considerations. And there's several of these things, obviously. These are sort of more or less sort of the standard stuff you'll see everywhere. So first of all, the issue of transparency. I don't feel that strongly here, but it is what I'm supposed to say. You're supposed to maintain a clear documentation. That's why I don't want to sign. I'm recording, I know, that's okay. No, it makes sense. If you're a researcher and you're using this in your research path, just like you have to document everything that you do in your little research lab log book, you would document this. Now, in reality, the part about transparency that makes sense to me is that I do now include in all my publications a little thing at the bottom there, acknowledgement. Large language generative AI was used in the editing, proof editing, workflow, syntax, whatever of this paper. That's fine. They wanted, they get it. That's what it is. It's never an intellectual property issue. Copyright and plagiarism is worse than you think. Well, I'm never going to plagiarize. That's right. So when you read a paper and you find this thing, oh yeah, this got to go into my thesis. you know that you're going to reward that, or you're going to quote it or reward it and cite it, right? I mean, there's no other way. Cite, cite, cite. The problem in the LLM is that it may cite for me, even my Perplexity is going to cite for me a paper or something. But when I give it a sentence, I say, say this. What's the best way to say this? Something. It's going to give me a sentence, which is the combination of anything. And it could be 1,000 sources, but if your research is really, really, really narrow in pediatric neuroendocrinology, and you're looking at this little thing, and you know that there's 5 groups in the world that do this. Now, you ask it a question about that, it will either hallucinate and says, oh, it's this, this, this. If you have gallstones, eat stones, and it's going to be good for you, and stuff like that, which is another problem, the bullshitting problem. But if it actually finds one of those labs that they wrote something or publication or something that they managed to scrape, and there's only one source it has for that statement, the word autocomplete is going to be just like on your phone. You know, when you rewrite a message that you deleted accidentally, and every word that comes, it's already the one that you wrote because it remembers. That's exactly what the LLM is going to do. And it's going to give you a sentence which is not cited because you didn't ask for citation and you don't have citations there. And that is going to be caught immediately in a plagiarism check because it's the exact sentence and you don't know that. So be very careful about unintentional plagiarism. As you know very well, you know, McGill and any university are pretty strong about plagiarism. So that just, you cannot say, well, my ChatGPT said this, and I didn't think it was somebody in particular, you know, because most of the time it's not. Most of the time it's 100 sites put together, and then what's the next word? But if it's only one site, that's what happens. Happens even more in non-Anglophone languages because there's much less content to scrape in non-English, in non-Anglophone, non-English language. And then finally, just recently, right, November 2024, McGill came up with the guidelines. I'm very glad that it took so long because they went past, thankfully, they got past the excitement and anxiety and so forth. So actually, the McGill things are pretty nice. It's a long text, lots of background. But what I wanted to show you is the actual. So this is what they do. Very nice what they do. They divide it by risk. Low to moderate risk using generative AI as a tool. What's the definition? There we go. See, proofreading, editing. I don't know if you can read from there, but you get the idea. It's that. Then you have moderate to high risk. Here you got literature reviews, producing summaries, the stuff I told you about. And then we go into very high risk, which you're not supposed to use, which is full programming, full research design, generating objectives, arguments, perspectives, stuff like this. Research design, conducting full analyses, writing entire sections, generating research quotations. So, in fact, I was surprised, pleasantly surprised to see that because I'm a defiant person and I'm going to break any rule that there is. And I went based on what I consider to be ethical. Actually, I'm good with that. I totally agree that that should not be used as such. And we'll talk about the subtleties of this. But we'll go now. How do I get this thing? I guess I have nothing I can do about that. And now I need to go back, not to this, just a second, to here. All right. And I want to get this thing off I cannot get it. Okay. So that was that. Then, right. So now a bit of a reality check on AI. And this is really funny because my talk up to here would have been where I would have been 6 months ago, but I've increasingly been thinking about this. And I actually owe a lot to this book. This is an actual book, AI Snake Oil. It came up just a couple of months ago, and I devoured it, and it was as good as the blog and the the podcast that they had before. These are two scientists and PhDs, and they really show you. It says what artificial intelligence can do, what it can't, and how to tell the difference. And there's so much snake oil. Now that snake oil, you know what that means, is a sort of cure for all and stuff like that. That's typically predictive AI. That's Google telling us, or Epic telling us that as a clinician, you can use this cardiac risk AI model, or you can use this discharge summary, discharge model, or you can use this ICU survival model, and it's going to help you care for the patients. There's unbelievable amounts of snake oil in there. And most of the actual capabilities of this hottest models that you see out there are purely in vitro, in silico, and they're zero or next to zero, next to Toscoin in real life. So all that stuff that you see, and there's so much of it, and I'm just getting so fed up with how it can answer the exam questions better than students, and how can pass board exams and all that stuff. The insanity of thinking that actually that's what makes you a doctor or a researcher or whatever, or a lawyer, because you can answer this Q&A, because it trained on these things and it knows how to answer them. But all those things are absolutely useless for when it comes to actually the patient in front of me. And the models, I've been myself, I went through the painful journey that lasted 3 years now. I wanted in the 2021, I think, I got my first CHR grant, big grant, on using machine learning to diagnose perforated appendicitis in kids. Such a nice project. And I was all excited. So we first had no data, because you need, for machine learning, you need data. So we spent 2 years, we're still finishing. After 3 years, we're finishing the collection of the 2,000 records from Oasis, which are there. That's how long it took to do that. And of course, a lot of garbage in the collection and stuff like that. Anyway, and then we had a computer science student, and she spent her whole master's, beautiful master's, on it. And she went through trying to fill the missing data. A lot of those sort of methodologies and imputations of various sorts, and then the models and comparing the models. And we found that we can predict it with about 75-80% accuracy, which is garbage, which is absolutely useless in a clinical setting. Your medical student that comes in front of the patient with appendicitis should be able to do better than that. And that's after we trained this model on 2,000 appendicitis cases that we had with all that stuff. So that was my personal understanding of why there's so much snake oil. When somebody tells you this model is much better than this model, yeah, but it's not going to do anything to the patients. And the scary stuff is that because there's billions of dollars in healthcare, mostly from down south, that is just cranking. And the fact that it's all black box, that there's no obligation to actually show your model because it's a proprietary model. So you cannot open the code to show what the weights are. Which patients did you train your model on? What weights did you put in? What data did you put in? They'll never tell you. And then they say, but look, we have 0.92. Our accuracy is 92%. There means zero. 92% was on a retrospective data set from 10 years ago from down south Texas, God knows where there's a big Kaiser Permanente or some big corporation that has a lot of millions of patients. Are those my patients? Are those anything relevant to me? No. We're not going to go into that because that's not LLMs. LLMs is generative AI, right? So generative AI are primarily bullshitters. Now, if you think that I should you should sort of mute me when I say that. Actually, that is an Oxford Dictionary term. And I want to refer you to that. So this is the paper. This is one of the papers that I used on it. I wish I could make it a bit bigger, on the reception and detection of pseudo-profound bullshit. And the key sentence here is pseudo-profound bullshit, which consists of seemingly impressive assertions that are presented as true and meaningful, but are actually vacuous. In fact, we enlarge it from pseudo-profound to any type of bullshit, which are basically statements said in assurance and full assurance. Yes, the answer is this, when in fact, it's not. And it's very interesting because I talk about this more than hallucinations, the bullshitting part, because the bullshitting part is built in, and it's very, very hard to untrain your model to stop BSing. But the understand that we'll talk about hallucinations in a moment. Let me just go back to this. So this is the problem with generative AI, and there's problems with the diffusion models. I'll show you. There's actually a third form. This is a slide from the snake oil about the three forms of AI: predictive, generative, and then content moderation. That's not our concern here, but it's about Facebook showing the horrible stuff that they do, despite the fact that they have thousands of people and models built to generate, to moderate the content on. So we're not going to focus, obviously, on that. So how do you use LLMs practically? A few simple suggestions. Provide ample context. When I do my medical stuff, and I use exclusively AI now to find medical information, because it gives me the resources anyway, the sources, and then I find the paper that I like for this. I always say who I am. I am a pediatric surgeon. I'm taking care of this child, and this is my problem. So that way, it doesn't BS me with stuff like, you should check your son's tummy. I don't need to hear that. Provide a context and include as many documents as possible. There's something about including documents as a way to pre-train, which is the few shot methodology, which means that I keep getting it better at the prompt I want by giving it examples. So if I want to summarize an abstract from 500 words to 300 words, if I give it 3 other abstracts that are 300 words, it's going to know better how to do it. And that's that sort of stuff. Or REB, for REB is very nice because I give it a model of an REB so it understands how you do that. Craft careful prompts. And the thing about it is that you create a scenario, the more you write in the prompt, it's better. It's funny, a year ago, prompt engineering came as the big thing, and that was the 6-digit job you could get as a prompt engineer. People rarely talk anymore about prompt engineers. It's not a thing anymore, actually. But it is important for all of us to know how to write the prompts, and you keep refining them. If it doesn't work, you refine it. And in some software, I'll show you in my Gamma, I put a prompt, and then it actually gives it says, do you want me to refine it for you? Like, let me just do it, write it properly. Is this what you want? Oh, good, okay. Explore multiple LLMs. Each one will give you a different answer, of course, by a little bit. Another thing where my bias, in which I have no financial investments, Perplexity, actually from the beginning, I pay my $20. It's the pro version. I pay my standard $20 a month, which all of these things, if you want to use them more, will require of you. And everybody in my lab has access to it anyway. But you can actually check when you rewrite, because you can sort of rerun the query. You can rerun it in the same, but you'll see that it has 7 languages that it can choose. And I can choose from my Perplexity. I choose ChatGPT. I can choose Claude. I can use smaller models, faster models, bigger models, whatever I want. Continue to iterate and refine. It always is work. You'll see that some of the prompts I'll show you in a moment are sort of a combination of, some of them are just one and gives me the answer. The other ones I have to go on for 10 minutes to get it to really understand what I'm trying to do. And then by far, the most important thing is the thorough review. Never, ever, 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 ever write something from ChatGPT, copy and paste it and put it in without reading it carefully. Without reading it carefully. That's where the real plagiarism, that's where the intellectual content comes in. Potential traps and pitfalls. Hallucinations. Of course, we all heard about hallucinations. Funny enough, hallucination is not an appropriate word for this because hallucination from a human being, and in psychiatry we know, is somebody who has a worldview. It's a human being. Obviously, they're a human being. And they come up with something that is not rooted at all in reality, right? They hallucinate. LLMs don't have a worldview. This is the important thing to understand. LLM didn't think, oh, I think that life looks like this based on everything I ingested. No, they don't. They just autocompletes. So what they give you that we call hallucination, and we swear at the LLM, what they give you is the statistically highest probability word that comes in their training. And it all depends on what's in their training. And again, I come to this problem that especially outside the English environment, it's pretty crazy because they were so desperate for multi-language translation and multi-language training models that they'll take whatever they can. I do know, for example, that, in some countries, there's very little internet content. Most of it is porn sites in that country. So guess what? That gets scraped, right? Because they're right there. Plus, in some places, it's government stuff that's allowed. And so you end up with aberrations and you wonder why it hallucinates. Well, that's why it hallucinates, you know? But that's so that we understand. And there's less and less hallucinations, which is nice. By far, biggest trap is the fake writing, the GPTisms. And we'll talk about a whole thing about common GPTisms. Unnatural language patterns. I live with that with my students. False confidence. We talked about BS. When they actually appear more knowledgeable than they are. We talked about that. Plagiarism. We mentioned about this good intentions are not enough. You don't think it's plagiarism. It is plagiarism if LLM plagiarized and you're using the LLM. And then much more interesting is this thing about narrowed and biased imagination. I can stop after this slide. Actually, that's probably, should we continue, or I guess there's people there, or whatever.
Continue, we'll take
and people can take, after this slide. I'll just finish the slide. It's the one next to it, because this shows the narrowed and biased imagination. This is something very interesting, and I'm very excited to have come across this thing. And it's illusions of understanding. And this is a paper from Messeri and Crockett, and it's Nature 2024. And it's just superb for understanding LLMs, because you've got three types of biases: illusion of explanatory depth, illusion of exploratory breadth, and objectivity. And what I mean by this, you see, is that for explanatory breadth, what I think is that these are all the hypotheses. I prompted LLM, it gave me three hypotheses for why something happens. See, well, that's all of that. When in fact, these are just the hypotheses that the AI figured out, right? Or they're testable with AI. So it's obviously, I think I'm deep, I'm not. What about breadth? Same difference. I think I understand. I believe that the concept X, I understand all of it, or 95% of this, because the AI explained it to me. When in fact, my actual understanding is just a tiny bit, because that's just what the AI knows. And that's another thing where the BS comes in a lot of times in there as well. And then finally, and even more scary, is the objectivity. And this is about bias, right? So I think, well, AI doesn't have any biases, which is baloney. AI has the combined biases of all humanity. That's a lot of biases in AI, right? Just think about it. Nobody says, don't be biased. Just scrape anything you can. And then good people will tell you to not be biased, and bad people will tell you to be biased, and all this stuff, right? That's why there's content moderation. That's why there's thousands, if not hundreds of thousands, of poorly paid workers, the so-called mechanical Turks, workers in low and middle income countries, paid $1 an hour to go through all the filth of the internet that OpenAI gets and continuously cut it off whenever there's garbage that comes out. It's a horrible ethical problem. But the bottom line is AI is not unbiased, and therefore its standpoint could be just as biased as anything else. And I can stop for a moment here if you want. For people for a break, we can take a sandwich and then continue from here.
So you can come and grab a food, and we'll just continue with the examples. Where we're at.
Hmm?
Examples.
Yes. Recording. Okay. All right. So now that you got good value from this meeting, those that are here on site, even if the talk is so and so, the food was great. Just continuing here because I want to question.
Yeah, just a quick question.
Yeah.
So McGill just purchased the institutional license from Copilot.
Yes.
Microsoft Copilot, encouraging all their faculty
Yeah.
to use Copilot
Yeah.
as a more secure version. You didn't mention Copilot as one of your preferred options for generative AI. What do you know about Copilot?
Yeah, it's just like the other ones. Copilot is just a Microsoft version of Gemini and so forth. It's just it's just as good and just as bad. It's got exactly the same issues and the same qualities and uses. I think that anything that I say here would I think apply to that. I don't have any specific statement about it. The reason clearly McGill's choice for this is simply a business choice. So to say that it's more secure than anything else, that would be very, very unethical.
Oh, really? Because I mean, on the website, they have a commercial data protection version.
Yes. Yes. So this is what on my Perplexity, there's a button at the bottom in the settings which says, do not use the training for data. That's right.
Oh.
Mm-hmm. Because the real full security for CIHR purposes, for example, for research purposes, needs to go way beyond clicking the button, do not use my training data. It actually needs to be that no data actually goes to the cloud, any cloud. And that's what we're doing in our lab. We basically get an open source language, which is Llama. Now it's Llama 3.1. Huge language, but they have a 7 billion token smaller version that we put on a server on our computer at core. It literally sits there. And then when we have a patient data, for example, that we want to use for and stuff like this, it's behind a firewall. Nothing goes outside to the internet anywhere. That's what CIHR will accept for real patient-related confidentiality. For educational, clicking the button that they're not going to use your data is probably very fair because none of us are in the military security or FDA or FBI or something like that. So here's a couple of GPT-isms. Before I want to get to the actual fun part to show you some stuff. But these are the things that for all the students here and for all your letters and for all your documents, please stop using furthermore, moreover, delve, illuminate, foster, highlight, all those things. It also often over-explains common concepts. It often uses frequent metaphors and cliches. And there's one thing that I can't get even Perplexity to stop doing. Anytime I ask a question, it gives me the nice answer, and then it has to give me a summary and conclusion. Like, stop doing it. I don't need it. And then there is the general stylistic tendencies, which is hyperbolic language, and that's what comes in reference letters and stuff like that. There's also this, what I call mansplaining achievements, which is in every reference letter that I get nowadays, it's going to say, so-and-so completed this master's course, which is a demonstration of their intelligence and stuff. Like, seriously, maybe to your grandmother, yes, but not to a reviewer. Everything that you do is explained, it's mansplained immediately afterwards. That shows that they're really bright. That shows that they're really innovative. That shows, no, it doesn't. Leave to your reviewers to decide what it shows. Just tell us what you've actually done and leave it there. But ChatGPT doesn't know how to do that. Oh yeah, a few bloopers just for fun. First of all, these were one of the early ones, the most popular one. This was this physics something, copper-based metal organic framework, very serious journal. Surfaces and interfaces, that means nothing to me, but I'm sure it's an important journal. And the main thing is it's a bit small to see, but in yellow here at the introduction, the first sentence is, certainly, here is a possible introduction for your topic. So that's the early days when they forgot that you gotta, when you copy and paste, you at least gotta remove this thing. This is about words used. So this is comparing a study. I went straight to the actual table in this scientific publication, comparing 2022 to 2023 papers in the same journal. The words intricate or meticulous or meticulously or commendable increased by 83%. Other words like notable, pivotal, invaluable, noteworthy, methodically, strategically, and so forth and so forth. You see, they all went up, and those are those are GPT-isms, right? And then for diffusion, for AI vision stuff, this is a serious publication that actually was put in a journal on the Sertoli cells of the testicle in this mouse. And it's obviously a very, very funny looking picture. It also represents something else, which is that if you actually carefully look at every word, except for the word cell here and the word rat here, there's nothing else, and cells, there's nothing else that's actually not misspelled. Completely misspelled. This is the same with the strawberry dilemma. It's very, very hard. Nowadays, I'm seeing more and more. We try, if you have very few words, it'll be able to put them in, but very hard for LLMs to do this. So that's publication bloopers. And then some gradient diffusion. This is just for fun, just to show you a few gradient diffusion. So this is a standard thing my students would put in, blue and nice background, a scientist, the he, she, not sure. But the cool thing is this thing here. So this young scientist is looking at their iPad with a huge magnifying glass, which they're not holding. Right. This is where you see what happens. This is my favorite because it's surgery. Yeah. So how many things can you get wrong? How many things did they get wrong? So what is it? What's wrong?
Mass.
Let's see 5 things. Mass. The mass so blends in the beard. I can just see that.
Finger also.
Huh?
Fingers, left hands.
Okay. 1, 2, 3, 4, 5, and the thumb. 6 fingers. Very good. More.
Head cover.
Yes. You're right. I didn't think about that. You're not allowed to operate without a head cover, even if you're bald like me. What else? There's more. There's more stuff. Just look at it carefully. You don't have to be a surgeon for this. Some of them you do. Huh?
He's doing the surgery looking at somewhere else.
Exactly. But he's not even looking at his assistant.
No.
He's looking between this guy and this guy. Now, look at this assistant who's got his eyes closed. And who's somewhere else on the abdomen. Because, by the way, that just doesn't, that would be the last day of that resident in the operating room, And then there's, the instrument in his hand. There is no such instrument. The instrument in his hand, which is held between the second and third finger, it's like it's showing you something. It's not, yeah. So yeah, that's just one. And yet it looks so beautiful, doesn't it? It looks a beautiful picture. This is when you're trying to to use AI for a sign. No smoking or drugs, but drugs are allowed. So please, guys, don't do drugs. That's basically what that sign is saying. Now, this is the classic one. This is what you see everywhere nowadays. These medical, healthcare, allied healthcare, nursing, maybe. Notice that these 4 students are extremely well balanced diversity wise. There's 3 black, 1 white. There's 3 women, 1 man. Hey, good stuff. Good stuff. What's wrong? Of course, the stethoscope has 2 ends. Yeah, that was that. That's just for shits and giggles, for fun. Okay, that's it. We're getting to the fun part.